All right.
Just look at him one day.
Tell me which ones we need to go over then.
1D.
E, and
1D and E.
and 3D.
Okay, one, let's, I can't,
3B. No, 3A.
Wait, what? No.
Okay, 1D.
Are you sure?
We need to find the length of the curve of, here is the position vector, 2t, t squared minus 2. This one looks kind of easy, isn't it?
No, but then I confused.
No, from t equals 0 to t equal 2. Okay, so it's going to be the integral
Wait, yeah.
from 0 to 2. Well, let's just see what kind of integral we get.
Uh,
So, the velocity vector is the derivative. So what is dx dt going to be? What's the derivative of that? 2t, and negative 2t, right? So it's going to be dx dt squared, so 2 squared plus 2t quantity squared plus negative 2t quantity squared dt. Now, is this integral easy to do? Well, let's see. 4 plus 4t squared plus 4t squared dt. Integral from 0 to 2, square root of 8t squared plus 4 dt. Factor out the 4, so you will get 2 square root of 2t squared plus 1 dt. Did we get that far at least? So we can get 1 point. You want
1 point.
Duh! So the other point comes from, can you do the integral? Is it on the list? No. Can I make a u substitution?
No.
Can I do integration by parts?
No.
No. So now you're left with trig substitution or partial fractions or the z substitution. But obviously it's a trig substitution, right? What would I let t equal to?
Wait, I thought root 2 tan theta would have.
No, it's 1, close.
That's why.
1 over root 2 tan theta. Because you have to cancel out that 2, that's why.
Oh.
Because if you go root 2 tan theta, then you're going to get 4 tangent squared theta plus 1, but that's not an identity.
Oh, so
Tangent squared theta plus 1 is the identity. So
You always want to try and make it match the identity.
yeah, that's what the trig substitution is.
Oh.
How come sometimes?
What, you just thought trig substitution is a random thing?
Yeah.
How come sometimes there's something in the front that's not?
Yeah.
making
Sometimes
sense?
you,
You know what I mean?
yeah. Cause like the 8.
Sometimes there's. Oh, because that's
Oh,
like the other number.
because the problems we had, the number was there instead.
Oh, that's.
Oh.
But now it's here, and then all hell is breaking loose. So dt is equal to 1 over root 2 secant squared theta d theta. So this integral becomes 2. Integral square root of 2t squared. See, when you square this and times it by 2, you just gonna get tangent squared theta plus 1. dt is 1 over root 2 secant squared theta d theta. And then what are my new limits of integration? What are my new limits of integration? If I plug in 0 for t right there, then you end up with tangent theta equals 0, so 0. What happens if I plug in 2 for t there? Then you get tan theta equal 2 root 2, so what is theta? Tan inverse 2 root 2. Wait, you guys don't like those numbers? And then, hey, you somebody. That's secant squared theta. And what's the square root of secant squared theta? Absolute value of secant theta, but over this interval it's positive, so you don't need the absolute value. So basically this is what you got. The integral root 2, integral from 0 to tan inverse 2 root 2 of secant cubed theta d theta. Now remember, when we did our integral review, I told you guys this would be a good integral to memorize. Okay, if not, then you got to do integration by parts then. But I am not going to do that again. I memorized the answer. The integral of secant cubed theta is 1/2 secant theta tangent theta plus 1/2 natural log absolute value of secant theta plus tangent theta. Now I don't care how you get it, whether you memorize it or you do integration by parts. You got to do it twice and then you got to bring it over. Not twice, but that's the one you got to bring it over, solving for the unknown integral. Okay, I think you guys can plug in the top number, bottom number, and subtract. The answer has been verified by Cho.
Where is he?
He already did this already.
Also he's here.
He verified it.
So no comment.
No comment. I'm not gonna comment on this. So don't ask me. Okay, so that's 1D. Now 1E. This is a fun one when you have to use power series. Can I erase this? Because we only can go on one side of the board since we're videoing.
Yeah.
Do you need to take a picture, Park?
No, I did it.
Very good.
Thank you.
Très bon.
Très bon.
Is that
It's French for very good.
You know French, but you don't know Korean.
No.
Sad.
Well, I never took Korean. Where am I
You
going to
took
learn
French?
Korean?
You took French.
I took French in high school and a little bit in college. Okay, this is two-dimensional. This is an insult to our loins. To t equal 1/2. Okay, so velocity vector, dx dt gonna be 1, and dy dt gonna be t squared. Did we get that correctly? So the length of curve is gonna be the integral from 0 to 1/2 of the square root of dx dt squared plus dy dt squared, which is t to the 4th dt. Now, this one I already told you already, that's very difficult to integrate, so use power series and estimate your answer to within. I'll tell you right now, this problem is on the test. You're gonna have to do power series. So what is the power series we're looking for? We wanna change this one. Isn't that the same thing as 1 plus t to the 4th to the 1/2 power?
Yep.
And then what are you thinking when you see that?
Fine.
Binomial theorem. Ha ha! So, a to the n plus
And what
n. The power of a goes down by 1, the power of b goes up by 1. That's the binomial theorem. 1/2 negative half over 2 factorial. The power of a goes down by 1, the power of b goes up by 1. That's the binomial theorem. Let's just do one more term for funsies. Plus n minus 1, n minus 2 over 3 factorial. The power of a goes down by 1, the power of b goes up by 1. That's the binomial theorem. Okay, is that enough? This probably might be enough. Okay, so here we go. What's the first term? I'll do the first term. 1. Ha, second term.
1/2 t.
Wang, third term.
Negative 1/8 t to the 8.
Negative 1/8 t to the 8th. And then one more term. Park. Plus.
Oh, 1/16 t to the 12.
Oh, you guys are on it. Okay, and it keeps on going forever. And then now we integrate it term by term. So we get t plus 1/10 t to the 5th minus 1/72 t to the 9th plus 1. What is 16 times 13? 16 times 13.
28.
28. I'm doing it already. 8, 208.
That's what I just said.
Too late.
Too late. 13 minus from 0 to 1/2. Okay, obviously, can you see when you plug in the 0, everything will be 0?
Yes.
Okay, so it's just a matter of plugging in the half. So what happens when you plug in a half? I'll do the first one. 1/2 plus, what the heck, I'll do 1/10. Now what is 1/2 to the 5th power?
1/3.
1/32. And then what is 1/2 to the 9th power? 1 over 512 plus 1 over 208. And then what is 1/2 to the 13th power? Well, 2 to the 10th is 1024. So 2048, 4096, 8192. Did I do that correctly? And this is an infinite series that is alternating. Starting from the second term, it's alternating, so we can use Leibniz's theorem. Remember the remainder? You guys got 5s on the AP exam last year. if you have an alternating series, does this sound familiar? Then the magnitude of error is always going to be less than the first unused term.
Oh, yes.
So we look for the first term that is less than 1/1000. Okay, so this is 1/320. Is that less than 1/1000? No, so we go to the next term. Is that less than 1/1000? Yep. So if you just add up the first two terms, the magnitude of error will be less than this, 1/72 times 512, but that is less than 1/1000, so therefore the magnitude of error will be less than 1/1000. Probably on the test though, what does this number come out to? What is 512 times 72? 1024, 4 carry 1, 3, 5, 4, 6, 8, 6, 3. So that comes out to 36,000. You know what I'm gonna do? I'm gonna force you go to another term. I'm gonna say I want the magnitude of error to be less than 100,000.
So many.
Then you gotta go to the third term.
So
That's not mean. I need to test to see if you remember these things. That's amazing, yeah, how you can get a 5 on the AP exam and then the next year it's just gone from the memory.
It's not completely gone, like, I remember it.
You remember some things.
Yeah. It's just, you have to like jog my memory.
Okay, so I'm assuming you can add up those two terms, make a least common denominator. So what is that gonna be? 160 plus 161/320 then. That's your answer. That was fun, that problem. I like that problem. That's why it's on the test. So just remember the binomial theorem and nobody will get hurt. Okay, what was the next one you said we're gonna do?
Oh, we're going to
Can you tell us how to
Oh,
find
yeah.
the path traced out?
For number 2?
And
No, just like 3A and like.
What about 2A?
Oh, yeah, that's it.
You just look at it, it's
No, but how do you
it's
like
an
just
ellipse.
know by
Do
looking
you
at
like-
it?
Because we did it in PCH.
like x equals.
Wait, it's a circle.
T plus b.
Oh yeah, it's A and A, it is a circle.
Paramedics.
You're right.
Oh, it's-
No, yeah, I like plugged in the values for
It's a
t
derivative, and then you.
and like I made a chart, but then is there like another way to do it?
Okay, look.
Yeah, I must have just.
A's
done that.
How do you find the path trace out by the part? Just remember, this is equivalent to x is equal to a. This is parametric equations, that's what
Oh.
this is. Y equals a sine t plus c, right?
Yes.
Now, what identity are you gonna use when you have cosine and sine? Cosine squared plus sine squared is 1. So isolate the cosine in the first equation. X minus b over a is equal to cosine t. Isolate the sine t in the second equation. Y minus c over a is equal to sine t. Square both sides. Ha-da-da. Ha-da-da. And then what do? Add or subtract or multiply or divide? Add, because cosine squared plus sine squared is 1. So you got x minus b over a squared plus y minus c over a squared equals 1. Isn't that the same thing as x minus b squared plus y minus c squared equals a squared? A, you want circle. Center at BC, radius A. Okay, and then what about the other one? Number 3. So this is our PCH problems. Wait a minute, time out. Did you guys already take the math level 2 test yet? Did it have parametric equations on it?
I don't know, it's super easy.
What's that?
Most people say they can't finish it.
This other
What?
time?
The math level 2 test, SAT 2, reasoning test. You answered all the questions.
Yeah.
Oh, that's because we're MVC, that's why. You guys all took it already.
What's that?
No, I take-
Math level 2.
I don't
I take it-
know.
Most of the exclusive colleges require it.
Oh, I'm not gonna go to exclusive college, so.
Okay,
Was it
so
like-
in problem
I thought it was within now.
3a, x equals 2 cosine 2t,
because
y
you're-
equals 3 cosine t. Well, when you see cosine 2t, aren't you thinking, A, what's the double angle identity for that?
1
You got 3, but which one am I going to use since that's cosine there?
1 minus.
No, 2 cosine squared t minus 1. And then in this equation, if you solve for cosine t equals y over 3, you can plug it in right there. So you can get x equals 2 times 2. What is cosine t squared? Y squared over 9 minus 1. And then I think you guys can. So this is like a parabola opening which direction? Up, down, left, or right? 1 out of 4 chance.
Right.
Right.
To the right. Because it's y squared. X equals y squared. Yeah, going to the right.
Or you can do it with 1 minus 2 sine squared.
Well, yeah, I guess you could, and then change cosine squared to 1 minus sine squared. Then.
No, and then do.
Oh, sine squared plus cosine squared is 1. Yeah. As long as you do correct mathematics, it'll come out. Doesn't matter if you eat strawberry oatmeal or blueberry oatmeal, it's just going to come out. Okay, whatever. Okay, so you're telling me that the calculus part of this is the easy part, and then the pre-calculus part is the hard part.
Yeah.
That's how it normally is. Okay, what do we need to learn today? Is this, we got one more to go, yeah?
Okay.
Is this the last one?
Yeah.
5? Yup, this is the last one. Curvature. Now what the heck is, now you got these two formulas for curvature. If the equations are given parametrically, then you use this one. And then if it's given like y as a function of x, then you use that one. So curvature is like it's a two-dimensional concept. But we can apply it to three-dimensional concept later. Basically, curvature is how much a graph curves. That's what curvature is. So like if you have a straight line, it doesn't curve at all. So what do you think the curvature is?
0. Wait.
Wait, let me think about that. Yeah, that would be 0. But what if you have something that curves like really sharply like that? Long, like a parabola. Then the curvature would be large. In fact, have you ever heard the term radius of curvature, like in physics? Radius of curvature? So, I don't know if it's by definition, but the radius of curvature is simply the reciprocal of curvature. So, according to these formulas, k is the curvature, so the radius of curvature is simply the reciprocal of that. Okay, so let's just concentrate on how to compute curvature. So we're not going to do those problems. Let's do a different problem because you guys need to practice.
What is the radius of curvature? Like,
Radius of curvature is like, okay, let's say you have something that curves like this. So can you imagine right at that point, okay, what is the radius of curvature there? Think of what the tangent circle would look like.
okay.
And then the radius of that circle would be the radius of curvature.
Oh.
So it's like a tangent circle. Okay, so here, let's look at something. Here, how about like this? Position vector is t minus sine t, 1 minus cosine t. Somebody tell me what this is. This is like the third time you've come across it. This is the
Heat.
what?
Oh!
The heat equation.
The
Helix, right?
the heat. No.
No, this is not the helix. Helix is three-dimensional.
Oh no! It's the half circle thing.
Oh,
yeah,
oh,
what is it?
no, I don't know.
What is it called?
Cycloid. Cycloid.
Okay, thank you. So if you have a circle and you roll it without slipping on a flat surface, the path traced out by the part of a point on the circle is a cycloid like that. So what point do we want to compute the curvature? Let's do it right here then, right there. What is the curvature of the cycloid right there? What is the value of t right at the top there? On the top, bro. On the top.
Power 2.
Pi over 2. Okay, so at t equals pi over 2, let us compute the curvature. Now, since these equations are given parametrically, look at the formula. Do we have to memorize this? Only if you want to get it correct on the test. X prime of t, y double prime of t. It's a formula, man.
So hard.
Y prime of t, x double prime of t. It's kind of easy to memorize. Just remember the absolute value. All over, what do we got here? X prime of t squared plus, wait, something's wrong there. There's a bracket.
Oh my god.
There's a bracket. Bracket squared plus y prime of t squared bracket to the 3/2 power. There you go. That's the formula for curvature if the equations are given parametrically, which they are. So remember, this is like x equals this and y equals that, right? Parametric equations. So we need to compute the first and second derivatives. So what is x prime? If this is x and this is y, what is x prime?
1
1 minus
cosine.
cosine t. What is y prime of t? Come on, this is
Sine t.
sine t. What is x double prime of t? What's the derivative of this?
Sine t.
Sine t. And then what is y double prime of t?
Cosine.
Cosine t. Did we do everything correctly? Yeah, we did. Okay, all we gotta do is plug in. So when t is pi over 2, we get the absolute value. Okay, x prime of pi over 2. Look at x prime. Plug pi over 2 into this, what do you get? 1. Y double prime. Plug pi over 2 into that.
0.
Oh, that's nonsense. Plug in y prime. Plug pi over 2 into that. 1. X double prime. Plug pi over 2 into that. You get 1. All over this to the 3/2 power. So x prime of t. Plug pi over 2 into this.
1.
1 squared. I'll even write the square. Plus y prime. We'll plug pi over 2 into that.
1.
Squared.
1.
Okay, so what does this all come out to? 1 over 2 to the 3/2 power. Which of course is 1 over 2 root 2, which is root 2 over 4. Yeah, I just leave it like that for you now. That's the curvature of right there. The bigger the number, the more it curves. And then of course, if somebody were to ask you what is the radius of curvature, then it would be the reciprocal of that number, which is 2 root 2. So if you think of it like a tangent circle right there, the radius would be 2 root 2 of the tangent circle.
Okay.
So it's just plug and chug.
Yeah, it's just plug and chug. It's pretty easy. Okay, I just want you to notice something before we finish. Right here, look.
Wait, that's all.
Look at 1b. This was on the PCH worksheets. Here's your position vector. Somebody impress me. Cosine cube t, sine cube t. What does that trace out? I'll give you a hint. It's kind of like related to the cycloid there.
A rose.
Okay, so how do you generate this cycloid? It's like you take a circle and you roll it without slipping on a flat surface, yeah? But what if you have a circle and then you have another circle whose radius is 1/4 of this, like that. And then what if you roll this circle without slipping on the big circle? What is the path traced out by that? You know, sorry, it's inside. Outside is something else. Okay, so here's the point P. Roll this circle on the inside of the bigger circle without slipping. What is the path traced out by this point right here? This is on the PCH worksheets. Hey, you somebody. That's called a hypocycloid of 4 cusps. You guys know what a cusp is, yeah? 1, 2, 3, 4, where the thing comes to a...
A stomach.
To a sharp point.
Yeah. But it's more than a sharp point, it's a cusp.
Okay.
Okay, so what would happen if you take a circle whose radius is 1/4 of this one and roll it on the outside? Now what is the path traced out by that point? Roll it without slipping.
Hypercycloid.
No. It's called an epicycloid.
4 cusps.
Yeah, you can put it in. So this is the parametric equations for the hypocycloid of 4 cusps. So if you were to graph it, it looks like this. That's a kind of an algebra. So what you are doing in problem 1B is you're computing the curvature right there. That's what you're doing. So just plug in chug and you can get a number, yeah? So let me ask you this for problem number 3. It says find the curvature of this ellipse. X squared plus 4y squared equal 8. Now, what are you going to do? Are you going to solve for y and then use the second equation? Or are you going to change this to parametric equations and use the first equation?
Change it for what?
Okay, I'll just pose that question to you and you guys try it. Because if you solve for y, look at that, you got to find first and second derivatives now.
Huh?
Make it kind of ugly. But it's going to come up. Like I said, blueberry oatmeal, strawberry oatmeal, doesn't matter.
Did you just come up with that?
No, he says it all the time last year.
I said oatmeal.
He did?
Never heard
I've never heard
blueberry
of it.
He's like,
strawberry.
oh, it's gonna come out no matter something really. He just
I've
changes
never
the
heard
food.
blueberry
Yeah,
strawberry.
Okay, we are
Yeah,
done.
he doesn't say blueberry strawberry, he says something else.
Blueberry strawberry is